Good evening, everyone. My name is Michael James. Welcome to day 2 of Engineering Insights, Expectation versus Reality. Now, we thank you for joining in or tuning in yesterday. We apologize for not being able to go directly live, but the recording is there on our platform for you to see. Now, today we are going straight live for our panelists of well-known engineers who know their stuff and are able to address your concerns. Today, day 2 is about addressing engineering truths, debunking myth to acquire actuality. Now, I am Michael James, one of 2 co-hosts. My next co-host is Cheval. Cheval, are you here?
Good afternoon, everyone. I am your co-host, Cheval Case, President of the Institution of Structural Engineers. And welcome to day 2 of our engineering seminar, our Engineering Insight seminar, where we look at expectations versus reality. This is the place for you to be if you would like to speak with individuals from your field. So at any point, feel free to comment in the chat below or also to send your questions. And yes, we will definitely address them. So thank you very much for being here. Thank you very much for those who joined yesterday. I hope you have watched the live before because our very first giveaway will be based on the previous live. Thank you once again for being here. Welcome. Our 7 panelists are more than willing to answer your questions. So remember to comment below.
And while they're there, remember to subscribe to the channel, share the link, let other engineering students near and far get active on our platform tonight. Tonight, we are addressing all your concerns, ask your questions, follow us on all our social media platforms. We're on Facebook at UTech Engineering. We're on Instagram at Engine Warlords. We're on Twitter at Engine Warlords 1. Subscribe down, the subscription bar is down below, subscribe and everything, and continue keeping up with us.
All right, so we're giving you 5 seconds to share the link with a friend. Are you ready? 5, 4, 3, 2, 1. We hope you've shared the link with at least 2 of your friends, and they're coming on right now. So this is a place where we have a wealth of information. Welcome once again, and we'll begin by introducing our panelists.
All right. So now our first panelist is Engineer Linkoy Small. Now, Engineer Linkoy Small is an electrical power engineer with 20 years of experience in the power and utility industry and is currently employed to the Jamaica Public Service Company Limited as a senior manager. He serves as Director of Systems Operations for the past 3 years. Now, he's currently a team leader of engineers who spearhead the execution of several projects and short to medium-term operations. Now, his 20 years of experience saw him working in several areas varying from generation power plant operations to grid operations and many more. Now, some of his major accomplishments came in 2016 when members of his team that had previously participated in a PPA negotiation of 880.3 megawatts new solar and renewable facilities supported the construction and commissioning process of the renewable plant, which increased Jamaica's renewable capacity from 8% to 17%, right? Now, to complement the increase in renewable energy penetration in Jamaica, Engineer Small was a member of the project team that commissioned the 24.5 megawatt of hybrid energy storage system to the Jamaica grid in 2019. Now, he has supported many projects throughout his experience, and he is a well-known engineer, very competent in his field, both here in Jamaica and internationally. Now, he is a technical consultant with various stakeholders with the Jamaica Public Service and Jamaica's energy sector. Now, in addition to his responsibilities, he reports the major grid disturbances events to all relevant stakeholders within the utility, regulation, and government organization. Now, Engineer Small has a Bachelor of Science degree in Electrical Power Engineering. He graduated with honors from the University of Technology. He has gone on to further develop his expertise in project management. Now, he has continued many studies and as a passionate engineer who not only is responsible for the training and developing of young engineers, he also shares industry experience on different and regional presentation platforms in areas, grid operations and planning and renewable energy. Now we want to welcome Engineer Small. And Engineer Small, could you just indicate to us who you are so we can see you and acknowledge you?
This is me right here. Hi, good afternoon, good evening, everybody. And are you?
Yes, we were hearing you clearly until we had a small glitch. Thank you very much, Mr. Small. Our second engineer is Mr. Ricardo Case. Mr. Ricardo Case is another electrical engineer. Now, this is my namesake, of course, so I take pleasure in introducing him. Mr. Ricardo Case is a professional engineer who holds a PMP. Very interesting, huh? He has over 30 years of experience in the field with a plethora of experience in management. He worked at Jamaica Public Service. He was employed there for over 19 years, and his record is not short of volunteerism. He is a past student of both the University of Technology and the University of the West Indies. Mr. Case, welcome, Engineer Case.
Thank you so much. That's a wonderful introduction. Thank you.
Thank you. Our next panelist is Engineer Jan Walters, Year for Women in Engineering. Now, she is a graduate of the University of Technology. She graduated with a Bachelor of Engineering in Chemical Engineering. She further continued to do her Masters of Science in Engineering Management. She was a chemical engineering intern at the Appleton Estate, Jamaica Rum. You know, she went on further to be a laboratory coordinator and laboratory analyst at the Caribbean Environmental Testing and Monitoring Services. She's the founder of GK Consultants and Services, and she's the founder of the Walk Good Project. She's currently a process control engineer with the Jamaica Company. Now, Engineer Jan Walters, could you just greet us for a minute?
Thank you, and good evening, everyone.
Along with Ms. Jan Walters, we have another outstanding chemical engineer, and that is Ms. Diane Plummer. Ms. Diane Plummer holds a Bachelor of Engineering in Chemical Engineering, as well as 2 Masters in Mechanical Engineering and Sustainability Engineering. She is a member of the chemical department at the University of Technology and is a business owner. These are roles that she operates simultaneously. She's the founder and CEO of Your True Shade. Ms. Diane Plummer, you were part of us yesterday, and we want to welcome you again today. Thank you very much for being present and for being more than willing to share your information and your knowledge with students. Welcome, Ms. Diane Plummer.
Having me today. Thank you.
Thank you, Engineer Plummer. Now, the next panelist is no stranger to us again. Mr. Hugh Gordon was with us yesterday and is back with us today. Now, this man needs no long introduction. He is a mechanical engineer. He is the founder of HTG Engineering Consultants, where they do mechanical, electrical, plumbing, and fire engineering designs, right? Now, Mr. Hugh Gordon, Engineer Gordon, could you just greet us again today?
Afternoon, everyone. Of course, a phone call is coming. Sorry. Afternoon, everyone. Thanks for having me here again. It was a good time yesterday, and I'm looking forward to even greater time today.
Wonderful.
Right. Awesome. Mr. Raymond Goldburn. Mr. Raymond Goldburn comes to us from the parish of Clarendon, where he worked with the Jamalco Company for almost 5 years. Now he is with Viola Water Technologies, where he has recently begun working. Mr. Goldburn, thank you very much for joining us.
Thanks for having me. Good evening, everyone.
Good evening. Now, our next engineer again was with us yesterday, Mr. Jervis Johnson, right? He is, of course, a graduate of the University of Technology, graduating with a Bachelor of Engineering in Electrical Engineering, Power and Instrumentation. He had worked at Kingston Container Terminal for 16 years. He's now at the Jamaica Public Service for 5 years. And one thing we need to note that he is a past president of the School of Engineering. Could you give us another greetings, Mr. Jarvis?
That's okay. All right.
All right.
So we have Mr. Norman Tai. Mr. Norman Tai is a professional engineer and another testament that youth can be great, right? He is a part of the civil engineering division of the JIE, chairman actually of that area. Now he works in the area of transportation and planning with NWA, that's the National Works Agency, where he focuses on planning, designing, analyzing highway transport systems. He majored in civil engineering at the US St. Augustine Institution, right? He is an active member of the Institution of Transportation and of Transportation Engineers, right, Mr. Tai? So thank you very much for being here with us, Mr. Tai, and welcome.
Thank you for having me. Looking forward to exciting and engaging discussions.
Amazing.
Wonderful.
Right into the meat of the matter, right, Michael?
Right. Now, we'll just allow our panelists, each of them, to give us a little greetings and explain to them, what they kind of do, what they, expect from this panel, and what they want to tell our students today, who are listening. And, we can start with Mr. Engineer Gordon. Since you were here yesterday, could you, speak to us today?
Sure. Well, let me give you a background. As you said, you gave a great introduction. I'm going to try and keep it short. But at HTG Engineering Consultants, we do mechanical, electrical, fire, plumbing engineering. A lot of design work, a lot of liaising with clients, liaising with utility companies, JPS, Water Commission, occasionally Flow, Digicel, and to some extent NEPA as well, to ensure that people's projects get built, people's projects get built to code, which is very specific and very important, and people's project be built on budget as it pertains to services engineers or services engineering. All right. Let me not keep up too much time, but essentially that is what we do at HTG.
Wonderful. Engineer Tai, what do you do at NWA?
Yes, good evening once again. Well, I am a transportation planning engineer at the National Works Agency, which I'm sure everyone is familiar with. We're an engineering entity for the government of Jamaica, where I do designs, geometric designs for roadways, highways, do traffic analysis, traffic management, and things of that sort. So it's I mostly work in transportation and highway engineering, and not so much in the structural and environmental side.
So when the roads are busy, we have you to blame for planning the traffic.
When the roads are busy, we have... I'll get into that later.
All right, wonderful. All right. Engineer Plummer.
Good evening again, everyone. Thanks for having me again on day 2. So what I do right now, I am lecturing in chemical engineering in the Department of Chemical Engineering at School of Engineering. So I lecture modules such as thermodynamics, fluid mechanics. We do the introduction to engineering, which is engineering tools, as well as some other courses. I also have a business called Your True Shade, where I manufacture makeup and skincare products, and I do consultations as well as private labeling and formulations for other brands.
Wonderful. Let's see, Engineer Small.
Yes, sir.
Just give us a small background, nothing more than 30 seconds, of what you actually do.
Well, you said it all in that bio, right? But basically, my responsibilities here entails, I am responsible for the operation of the entire grid. That's the transmission, the distribution, and the generation system for the entire country. So I, in a sense, determine who gets light, when, where, how safely, and how economically, right? From Morant Point right to Negril Point. We do some amount of short to medium term planning That means we go to from day to day out to a year, right? And we also liaise with a lot of different energy stakeholder groups in energy sector, not just electricity. So where it comes on to bauxite, when it comes on to water, where it comes on to fuel and in transportation, right? All of that is tied back into the energy sector because right now the grid is moving towards the development of electric vehicles, right? To help in not only in private transportation but also in the public sector.
Yeah, man. So I'm sure persons in the chat are getting ready to ask you, how come?
Mm-hmm.
All right.
UTech enables me to do everything. All right. So UTech is the answer as to how come. UTech empowered me to be an engineer that I am today.
All right, wonderful. Engineer Chase, Engineer Ricardo.
Yes, good afternoon, everyone. Currently, in my day job, I'm the Director of Engineering at JPS, where we have the awesome responsibility of engineering the grid of the future. We have several different, I'm responsible for several different teams and functions. Some of them include the geographic information systems and the deployment throughout the network, engineering planning, transmission and substation designs, construction, integration of renewables to the grid. So we do the project management to include those large-scale power plants to the grid itself. I mean, I know I'm going to leave out a whole lot of things, but in a nutshell, I wear many hats. I work very closely with Linkoy. We're responsible for the very long-term planning of the grid itself. So we're already looking at the grid up to 2037 and beyond, and ensuring that everything fits and integrates, all the pieces of the puzzle is aligned. A lot of what I do is project management as well. So we develop and implement projects.
All right, wonderful. And here's where we're bringing Engineer Jayan.
Hi, good evening, everyone. As mentioned before, I'm currently a process control engineer at Jamalco. So for those of you who don't know, a process control engineer is responsible for the automation of the plant's processes, more so from the software side. So I'm responsible for configuring control schemes, configuration of interlocks and logics, and overall, as you can imagine, a chemical plant or a plant, as a matter of fact, has numerous process targets that must be met, and controlling those manually would be extremely difficult and can lead to a lot of waste. Basically, process control provides a mechanism for automating the control of these processes so that we optimize our process and improve production, safety, and responsiveness.
Wonderful. All right. And Engineer Ramon Goldberg.
Okay. Good evening, everyone. Good evening again. So in my current role, I am a product engineer with Veolia. Veolia is the world leader now in water treatment in the industry overall. So the team that I'm a part of, we focus on industrial clients, predominantly in the beverage and the paper industries, in light industries in general. And we design and execute water treatment projects. So currently, I look at projects from the ground going up. So from the PNID stage, developing the drawings, drawing the tanks, drawing the process, putting together the best process for each application. So for example, customers are a wide range of customers from Hershey Chocolate. They are near to where we're based. We designed their plant to treat all the water from the chocolate manufacturing process. Beyond the meat as well, we're looking at their wastewater. That's a totally different challenge than Hershey, for example. So that's what I'm focusing on now. Previously, I was at Jamaica for 5 years, as we had mentioned earlier. That was great as well. I was a process engineer there. I worked a lot with energy management there as well. It's great to see the energy team here from JPS. That's really, really good to hear from them. So just looking forward to contributing, but also learning from the other engineers as well.
Thank you very much. Thank you very much, team. We have Mr. Johnson has joined us. Welcome, Mr. Johnson. Thank you for being with us tonight. And of course, we'll be speaking with you further as we go along. Now to our viewers, we promised you that we had giveaways for you, and I cannot fall back on my promise. So here we are. The first giveaway is to the person who is able to answer the question I'm about to ask. Now, we know the issues with day one, but we also premiered it this morning at 9. So for those who watched, this is your turn. Text into the chat what was the topic for yesterday's session and the name of one speaker in order to win this giveaway. Text into the chat the topic for day one, as well as the name of one of the speakers, just one, and that giveaway will go to you. So I'm watching the chat to see those, and in the meantime, we will move to our general questions, just some questions to get us familiar with the field that we are about to dive into. So Michael, take.
All right. Now, just a few general questions just to warm up our audience to have an understanding is, why did you choose the field that you're in? Why engineering, and specifically why mechanical, why civil, why electrical? Why did you choose this field? And we can start with Engineer Norman Tai. Why civil engineering?
Well, if I am being totally honest, as a young boy growing up, having done the technical and vocational subjects, my initial desire was to go into architecture, but having gotten a full scholarship to the UWI at the time, I was then presented with the opportunity of studying civil engineering. And I weighed my options. I thought about, should I go into architecture versus engineering? What are the pros and cons, the marketability of each? And I decided to go into civil engineering. I've always had a love for the built environment. So it is with that love really that led me into the path of the built environment. And then having the opportunity to study at the UWI, going directly into civil engineering. And I must say that I am loving the field, loving civil engineering. And I am glad I made that switch. And if I had the opportunity to do it all over again, I would make the same choice.
Wonderful. Engineer Plummer, why engineering?
So I chose engineering because I was always good at science, and I was really interested in finding out how processes work, how things work. So I would always be watching all these documentaries in manufacturing and all of that. And I used to be a tomboy when I was growing up and all of that. So, would pull apart things with my brothers and cousins. And that's where the love for understanding how things work, came into play. And I went into chemical engineering. I also got a full scholarship at the time. So that drove me into doing it as well. Then I moved into mechanical engineering for my master's, because when I was doing chemical engineering, I was always interested in energy. I fell in love with thermodynamics and those modules. So I wanted to go more into it, and that master's allowed me to do that as well. And yeah, and I always seem to be getting scholarships, so I just decided to, venture off into those fields.
All right. And another woman in engineer Walters, why engineering? Were you as lucky to just get a scholarship and decide, all right, let me just stay in this because I got a scholarship?
Well, actually, I did get a scholarship from a tertiary education, but that was not the reason. I wanted to become an engineer from I was 12. I was inspired by my granduncle. He was a biomedical engineer, and it just so happens that throughout high school, I excelled in the sciences. I had a knack for problem solving, and it was only natural. It just felt like the natural course. In fact, I didn't even consider any other area in the sciences when I was applying to school. Normally, they would say pick a first and a second choice and a third choice. I only picked one thing. I picked chemical engineering, and I got lured into chemical engineering. At the time when I did my CXCs, I did extremely well. I got 9 1s and I got 1 2 in chemistry, and I thought, whoa, I wanted something that would challenge me. So I opted for chemical engineering, and I also fell into the trap. Somebody told me, hey, you know, you're a girl, you should do chemical engineering, which maybe was foolish advice, but it turned out pretty well. I really, really love chemical engineering. And I think I'm lucky to be working in another aspect of chemical engineering, which is process control, which I love, and I really, really appreciate it. And I love how the role of a chemical engineer and a process control engineer challenges me every single day. And I don't want to be too long, but it also inspired me to do my master's in engineering management because I got so interested in simulating processes and optimization of processes.
Awesome, awesome. Thank you very much, Engineer Walters. So we've heard from our chemical engineers or civil engineer. We want to hear from our electrical engineer. So Mr. Case, why is it that you chose the field that you chose?
Well, to be honest with you, up to fifth form, I thought I wanted to be a doctor. And the only reason I wanted to be a doctor was because my mother wanted a doctor, right? But then when the results came in, after all that hard work on bio, I only got a C. I was depressed. And my uncle, who is my mother's brother, who was an accomplished engineer in Canada, sat me down and said, stop fooling yourself. You have been an engineer from, your mind works like an engineer from you were very young. And then he put me on a path. I think I had a good mentor. And from that, it's just upwards and upwards. So I enrolled, and I got a scholarship as well. So I had academic support as well, right through.
Thank you very much, Engineer Case. Now, I hope you're seeing I hope you're seeing the trend students, you know, I hope you're seeing those scholarships after scholarships after scholarships. If it's one thing we know is that engineering costs money. So you know where you should be aiming, right? All right. Thank you very much for sharing your stories and for sharing some background so that we can actually, quite a few students, I'm sure, can relate to the stories that you've shared. So I'd like to ask to Mr. Hugh Gordon, what percentage of your day would you say is spent in the field?
Wow, that's an interesting question because, as I said, my particular role as engineer and also managing director, it gives you different hats to wear throughout the day. So, for example, last week, 85% of the day I was not even in office. I was out of town. I was in the Grill. I was in Portland. I was in Ocho Rios. So it varies, and that's kind of what I love about engineering. There are times when yes, we have our desktop jobs, and I'm here and I'm sitting and I'm writing reports, and checking what's the next process, checking designs. But there are times when we're out there, and I know almost every road in Jamaica. I've traveled over the 20 years. I've traveled almost everywhere in this country to a site, to an inspection, to a job. And it's one of the things I just love about doing what I do here and what we do at HTG Engineering. So to answer your question, it varies.
Thank you so much, Mr. Gordon. So it varies. That's the essence of it. Thank you so much. I'm sure other engineers agree. Let's see. Ms. Walters, do you agree? What percentage of the day would you say is spent in the field?
Well, I'm a process control engineer, and as I mentioned before, I see Ramon is smiling because he already knows the answer. So It has to do with automation of plants processes. And the beauty about process control engineer and automation is that I can actually, at home now, I can actually view the plants. I can view most of the operational areas, all of our operating levels, temperatures, exactly what is happening. If I need to make a phone call to someone or operator or technician to take a look at something or have something resolved, I can actually do it from my desk. And a lot of my job involves configuration of control scheme and looking at historical data, which we have access to. So a lot of my days are actually spent by my desk, and a lot of my time is spent around my computer doing configurations, optimizing the processes, looking on historical data. And I mean, being in process control, you kind of have a bird eyes view at all times of the process, which I really like, but there are occasions when we're working on projects and we're commissioning projects that will require me going outside in the field.
Awesome, awesome, awesome. Thank you so much. Wouldn't it be amazing if construction could be automated? But I mean, Mr. Small, share with us, what percentage of your day would you say is spent in the field? We can see that it varies based on your portfolio, but share with us.
What percentage of my day spent in the field? Probably on average, just say about half an hour at any given day. As a senior manager, most of our work is strategic, right? So one thing that we do a lot is spend a lot of times in meetings. In fact, if you look in my job description, you see meetings, meetings, and more meetings. That's in the JD, right? And then on occasion, what we do is we might go out in the field to do checks and reconciliation on some things, work with engineers who are in office or those who are doing studies. Right, so it's a mixture of both, right? I get to travel the world like you, right? In terms of that's in local in Jamaica, but what we do from time to time as well, in order to ensure that we understand the benchmarking standards that exist in the field of electrical engineering, especially power engineering. One of the things we do a lot is travel overseas, right, and meet with different other utility companies, other different marketing companies and vendors who will be engineering products. So we might not be moving around a lot in the country, but there was a year in which I remember I spent about 25% of that year in planes, right? Just going around to different countries to see what they have to offer and then see how best we can apply some of those things to Jamaica. And Ricardo Case, who's on the call, and Jervis Johnson, that's a part of their daily lives as well.
Okay, thank you so much. Thank you especially for bringing up the points of meetings, which I'm sure all of you have a lot of those, right? So we're aware that, you know, as engineers, this will be our responsibility. So as it relates to meetings, Mr. Jervis Johnson, as it relates to meetings, how frequently would you say you have meetings? How important is it that you are prepared for those meetings, that you're ready for those meetings, and that you're on time for those meetings?
Well, let's put it this way. How frequently am I in meetings? I'm always in meetings. I'm just coming from a meeting into this meeting. All right. It's like a feature of what you do, of your job, as an engineering manager. And especially, I mean, it starts out with all engineers, you know, the people I lead are all engineers. And they are constantly in meetings from one planning process to another, from one design revision to another. So you find that all day, throughout the day, it's either meetings or training and things of the sort. You're always engaged. That's what it's like.
That is wonderful. Well, so question, a little follow-up question for each of the panelists, right? Now, since you're in meetings a lot of times, and I'm assuming these are meetings that don't only have engineers that are specific to your discipline, right? Now, what are other things that I need to know that might cross disciplines? For instance, I am a mechanical engineer, but I need to know something civil related or structural related, or I might be a civil engineer, but I need to have information on HVAC What are some crossover things that you need to know in the different disciplines that may cross over to other disciplines that you need to know going into some of these meetings?
So
yeah.
So if I may, that's one of the reasons why you have these meetings, because they're cross-functional, all right? And some of the activities that you are going to do have interdependencies. I'm an electrical engineer. There are interdependencies with the mechanical engineer, with the civil engineer on projects, and so on, with the chemical engineer as well. So you want to make sure that whatever process you're pursuing, whatever the end goal is, you want to make sure that it is achievable. You want to make sure that everybody is on board and on the same page. So you find that inside of that meeting is going to have an interdisciplinary group, right? You may even have people from finance in some of your meetings to make sure that, and procurement, to make sure that there is alignment with whatever it is that you're pursuing. So that's really the crux of the matter and the reason for the meetings.
One of the things I can probably even add to that is that all the classes that you attend at UTech and you wonder why you do them and you don't take them seriously. Econ, entrepreneurial skills, communication, those classes actually have some benefit, right? So you might have think I just doing these things to get a grade, right? I did 4 meetings today. The last one was with financiers, persons in corporate communication and marketing. I'm an electrical engineer. I'm already in a grid, right? And I have to be dealing with that, the financing, right? That goes behind the grid, the PR, as well as the human side of it in terms of the well-being of customers. So when you look at all the classes that Mr. Isaacs and all your lecturers give you, right? And you wonder, maths and all those things, and maths, you do maths till maths turn numbers. Words. Yeah. Laplace and all those things they don't take seriously. Yeah, man. They have relevance, right? Because as an engineer, and especially as a power engineer, why I like power, encompasses all areas to me of life, not just engineering itself, right? It deals with the electrical part, mechanical, instrumentation, chemical, finance, IT, education, architecture, everything, right? So that's one of the reasons why I like power. And lo and behold, in my 20 years of engineering experience, everything that I learned in UTech, I had to come out and apply it in the field.
And one thing I'd like to add to that as well is that coming out of UTech, it'll be impossible for you to, as a civil or chemical, mechanical, electrical, it'll be impossible for you to grasp everything about all the other disciplines. So depending on what company you're in and the context that you're in, over time, you'll have to learn what you can from the other disciplines to make your job and to provide value in your position to the company. So if you're a chemical, but there are mechanical aspects of a project, civil aspects of a project that you need to grasp, then you just need to spend the time on your own. If you're gonna get a mentor, if you're gonna get some help to get your skills up to par so that when you're in these meetings with a cross-functional team, you can put in some real solid contributions. So you don't wanna enter a room as a chemical engineer, but not be able to add some value when the other team members are discussing a topic. You wanna be able to add value. So if it means that you're gonna spend some time on your own and study up something, learn from your friends, lean on your mentors, the leaders in the company, then do that. So you'll have to spend some time on your own over the course of your career to improve your understanding of the other area. So coming right out of college, you won't know everything, but UTech gives you a broad base, which when you head out into the world, you'll really have a good toolkit to work with. So over time, you're gonna spend some time on yourself to develop yourself over the course of your career.
And speaking on developing yourself, okay, right? Go ahead.
Oh, yeah, sorry. I was just about to add as well that irrespective of your field of engineering or whatever your specialization is, I think it is critical for emerging engineers, young engineers, to understand that whatever project you're working on, whatever design, whatever element you're conceptualizing, it will never exist in a vacuum. It must rely on some other system, some other element. So it becomes therefore pivotal for you to understand how my project, how my design, how my structure operates within the context of other elements. So definitely you're going to need some understanding of other aspects or fields that you might encounter in your field of work.
Michael, I would like to say, for me, what is the problem being solved? That is always the elephant in the room, especially when you have cross-functional teams, as Jervis said, in a room. People often forget what is it that we're trying to solve. And you end up going in several different directions away from the solution. And that's where you have egos and other things leaking into productive sessions, right? So the focus, I think, what engineers bring to the room is what is the problem being solved. Of course, there are several ways to solve a problem, right? You can have the Rolls-Royce way, or you can have the Toyota Corolla way, for argument's sake. No, not picking on a Corolla right now. But there is a way, and I always believe that the solution is in the room. And no matter what, when you have the brain trust of so many different people in the room, a solution is there somewhere. But oftentimes, even as engineers, we get caught up in one aspect of a solution and forget what is the problem being solved. So if the problem to be solved is we need to reduce rates, then engineering is just a part of the puzzle, but it might not be the whole thing, if you understand. You might have a technology aspect, so it's a relay being run around different people where they have different inputs.
Awesome. All right, thank you very much. I was happy to see each person jumping in to give their comments on that particular topic. And I did get exceptional takeaways. One of the things that stood out was where I'm not sure which person exactly reminded us that we have to learn from each other because our fields are integrated. And someone else said, our projects will rely on other elements that are outside of our field. So we have to always be continually gaining information, but not only learning, drawing on others that are around us. So thank you very much for that information. Thank you very much for sharing your knowledge thus far. Michael, we move now to our second giveaway.
That is right. Now, let us see. Now, first, for our second giveaway, there's two things you need to do. First thing, subscribe to the channel. The next thing, follow us on Instagram, right? We're there at the bottom right here. I'm sure you guys can see all the handles, right?
Yes.
Follow us on Instagram, right? We're about to have a credit giveaway, so make sure you do that real quick. You know, follow us. We're giving you like 3 seconds. Like 3 seconds. 1, 1.5, 2.5, 3. Have you subscribed yet? Have you followed us yet? Now, get ready for our question. Now, if you've been paying attention, there are a few things that you should be able to pick up and answer for this credit giveaway, right? Now, let me see. I don't want to make it too easy because the first one, Chevelle, you gave away a very easy question. I'm sure someone got that already.
Michael, let's make this one very, very easy. Let's just give them the numbers to this credit. What do you think about that? Very, very easy. Because I know they've been paying attention and I know they're waiting for their turn to ask their discipline-specific questions. So what do you say?
All right, you just want to give away everything like that?
Just this one. Just this one. I know they want it.
All right.
So we have this credit for you, right? Are you ready to set the numbers?
It is a flow credit.
This is a flow credit.
All right, hold on. Let me get my phone first.
All right, Michael, don't you dare. All right, so the numbers are 181, 08.
Wait, hold on, pause. They haven't subscribed yet.
Oh, hit the
They haven't
button.
subscribed.
If you
All right,
don't,
so we're gonna have to start over again.
hit the button, guys. Subscribe right now. We're talking to over 40 persons currently present. So let's send the subscription up. You can also click the bell in order to receive notifications. All right, we ready? Should I
Let's
give
go
them math?
again.
Should I give them math? Yeah, like 15 plus 3. All right, no, I won't do it.
No, that's too difficult. Let's go. Let's go.
It's 181 08 1603 27897. If you've received this credit, please send it into the chat. All right. So in case someone didn't receive it, then it is 181 08 1603 27897. Amazing. Thank you so much for being here, viewers.
It is a flow credit, and somebody said they got it already.
Yes.
I see as well. I see
Joel
Kingman.
Richards.
I see Joel Richards. Well, Philip said he got that a long time.
Okay. Oh, no. He was saying he subscribed long ago. So Joel Richards, salute you. Thank you for joining us tonight. There are more giveaways, so stay tuned. Right, Michael?
Yes, man. Yes, sure.
We now head into our next session, which is the next segment, which is our discipline-specific questions. So the discipline that we'd like to begin with, and of course, remember at any time to send your questions into the chat. The discipline that we'd like to begin with is our mechanical engineers. So Mr. Hugh Gordon, yes, you're going to need that hydration. So there is a line of thinking. Ooh, Michael, take it away. I know this is your...
I am a budding mechanical engineer, right?
Yes,
and a few of my friends, I know that you have a consultant firm, so I hope you can speak outside of, consultancy, right? Because some of us have a line of thinking that, mechanical engineers, we just mainly like the maintenance, and the only time we use our brain is really when new machines are coming in, right? Or for some instances, when we have consultants firms or contractor firms, we're mainly behind the decks, So what exactly happens in the field, apart from meetings and going from site visit to site visit? Is there anything physical that I do instead of being around a desk or waiting to maintain something?
Let me tell you, when I was at UTech, I heard the same thing as well. I was destined for Red Stripe or Jamaica Private Power, working on one of the engines or something to that effect. That's what I heard. I was lucky enough to fall into consultancy, and it's different from the day-to-day. Or what I heard back at UTech, where you'd be just doing rough stuff using your hands, changing belts, changing fans, liners, hoses, and that's kind of why when my eyes were open to consultancy, it changed things in that I was able to do more design work. So we're designing air conditioning systems, cooling systems. We're checking heat loads for buildings. We're looking at electrical design, electrical distribution. Let me try and focus on mechanical. So air conditioning design, we do it. We do plumbing systems. We do to some extent sewage systems. So it's very challenging in. Go ahead.
I'm saying everything you speak about seems heavily on designing.
Well, as a consultant, that's pretty much what we do. We design, it's mostly design, pumping systems, AC systems, so it's heavily design oriented. And what is also necessary for us is to, keep up to speed with what new technologies are out there in our line of discipline, and also our local and international codes. Because that's what the building design is also mostly towards buildings, commercial buildings, residential apartments, and such industrial systems.
So speaking more on like the technologies and everything, I love AutoCAD, right, and everything like that. And some of my friends, we love drawing and all of that. But is AutoCAD still relevant? Is there a shift from AutoCAD to maybe, let's say, Revit for mechanical engineers when it comes on to MEP?
AutoCAD is very relevant. I mean, Revit is the way forward. The issue with that, without going too deep into it, is that we need to get the architects more involved in Revit. You know, and a couple of architects are going that route. But we really need them to prepare the drawings in that state, in that BIM type technology, and then pass it on to us so that we can twist it and turn it and see how things put together. So very few architects are doing that using Revit because we have versions of Revit here. But the thing is, without an architectural design, it makes our work that much harder because now we have to actually draw the walls and fit out the actual building before we can apply our designs to it. So most of the times we work in AutoCAD, it's quicker. You know, most architects have that and readily and easily share that. And not only that, we also have other architects using like Vectorworks. So, you know, there are challenges there. But AutoCAD is very relevant.
It's still relevant. A bit of a different line of questioning now. You're a graduate of the University of Technology, right?
Correct.
All right, and I'm sure many of your friends are group mates that you were with. I'm sure not many of them stayed in Jamaica, right?
Yeah, some are still here.
Yeah, right. No, but a few are abroad. So could you perhaps describe what difference it is from working internationally versus working here locally?
Well, I probably can answer that question by putting myself in that situation because I've worked to some extent internationally. I've worked regionally as well in Barbados, and it's pretty much the same because we've also worked with international architects and international engineers on projects in Jamaica and overseas. And what I said earlier in terms of codes and standards, that's true throughout region, throughout boundaries, throughout barriers. It's the same. You have to ensure that you have your codes and design to codes and standards. If you don't have access to that code, especially like, for example, NFPA 13 fire code, you can get it online. So we invest heavily in all our codes for design purposes. And what we will see is like, for example, some of these European hotels, like the Riu and such that are coming to Jamaica, when you look at their designs and we're asked to review some of their designs, it's similar language. You see the design, you see the codes, you see the standards that they have put into their design. So it's an easy handoff, it's an easy sign off on some of these systems.
So question, what are some areas outside of like consultancy and all of that me as a mechanical engineer leaving UTech can go into?
Outside of consultancy, well, let me see. Well, there is the typical ones that you all have heard and know about, like at the Red Stripe and the JPS and the private power company. Those are the ones that I really know of. And then you also have, you know, air conditioning companies like RL or CAC, Geddes. You know, they always require engineers on board. What you also more see now is contractors. Contractors need to have mechanical engineers, electrical engineers on board on their team. And there are a lot of projects, a lot of contractors that are, I mean, construction right now is a big push during this COVID period. You know, construction didn't stop. It may have slowed down, and you may have one or two that may have stopped, but on a whole, construction was still going on. So, you know, these contractors need to have engineers on board. So those are some areas that you know, you can look to, you can apply to, and see, you know, what offerings are there.
So question, I remember hearing you speak about price range or money in yesterday's session, right? And I know we spoke about, you know, not going after the money first, but with the different disciplines and persons have been pestering me to ask you, you know, give us a range, you know, how much is the money? Is the money really worth it in the different things I can go in as a mechanical engineer, you know, the consultancy money versus the range for the contractors versus, you know, power plants and all of that. Could you give us maybe a range for some of these?
I've been in consultancy for over 20 years, so I really can't speak outside of that. The money is, it's not bad. I've tried to set up my company in a way that is, you know, rewarding for the team. I'd look at our remuneration right throughout the year to see how best we can, you know, encourage the team to, you know, continue what they're doing, and also to, you know, look at new engineers that are coming in and how to actually treat them and ensure that they are, you know, properly remunerated. Because I mean, it's difficult out there. And I mean, yesterday's session, I know we had said that look at the experience, look at, you know, how what you're gonna get out of the position or the practice. But I mean, you know, that is true, but they also are hit with student loan, typical expenses that you have to pay as you leave school. So, you know, knowing what is out there or what your value is when you're leaving engineering school is important. And it ranges, as I said. I mean, it can be started, as I said, as low as 120, 140, and it goes, you know, sky's the limit, really. Based on how you,
is the limit.
based on how you work on projects that you work on. So it varies. I can't give you an actual figure.
Mr. Gordon, before we move forward, there's a question from the chat. Teddy Alexander asks, do you use SolidWorks? That's a software he was referring to. Do you use SolidWorks currently?
I know it, but unfortunately, no, we don't use it. If he uses it and see where we can use it, I'd love him to drop me a line and, you know, let me know how best we can integrate it. Something that we can talk about if possible.
Okay, so what you're saying is that you're open to the use of these softwares if you can see how they will benefit you.
If it can benefit us in what we do, because I'm always looking at ways to, you know, improve the efficiency of what we do here. So if it's something that can help our team, sure, I'd be open to it.
Amazing. All right, so thank you very much, Mr. Gordon. Onto the electrical field, Mr. Jervis Johnson, Mr. Rick Case. And who am I forgetting? The third electrical person.
Lincoln.
Yes, Mr. Small. Thank you. So it's your turn now to really just take the dance floor and bring some light to our electrical engineering students, right? So we want to know, there's a line of thinking in Jamaica that there aren't really electrical engineers, and that most of these, the only work that is really out there is technician work. So can you comment on that, fact or myth?
Who wants to go first?
Mr. Jervis.
You go then, Jervis.
You go on, Jervis. Then.
All right. So I know that I've heard that when I was in school. When I was in UTech, I heard that as well. That, you know, there are a lot of engineers out there in Jamaica. They're just really glorified technicians. Really and truly, having been in the field, we realize that Jamaica has some of the best electrical engineers that you can find anywhere. And we know this because we interact with engineers from all over the world. We meet up on projects, major projects across the island. You know, we just did a 190 megawatt plant that opened up for commercial delivery in December of 2019. That's 190 megawatts of power, replacing the old harbor units. And we are in the process of looking at another 171 megawatts of power plant that should be installed. And we've interacted with international engineers on many different projects. And you know what? What we have found is that we are among the best in the world. Because we have come upon challenges with which our counterparts from what we'd call the more developed countries have struggled with, and an engineer will stand aside and watch him struggle with a task that we know that we can do, and we allow him to try, and after trying, we just ask him to give us a moment, and we go ahead and fix it. And he's amazed. He's amazed because he comes to Jamaica with a mindset that this is a third world country and these guys don't have the skills that I have. And I stand there and watch persons from international organizations trying to recruit on the spot people from our organization. So what it says to me is that we are among the best. What you're learning there at UTech, and I heard a gentleman from you, is what is established and practiced around the world, right? So you shouldn't feel any less than anyone else, and you shouldn't allow anyone to tell you that what we have going on out there is just technician work and not engineering work. There is a lot to be proud of, and we have seen it. And I believe all of you guys that are there, you're learning your craft. Be very respectful of it. Don't count yourself as lower than anybody else. Linko, I mentioned something that is very critical, that it's not only about the mathematics and the Laplace transform and the Cauchy-Riemann formulas that you learn and the complex math that we do. There are so many other facets to engineering and to electrical engineering that's very important. To any engineering discipline, that's very, very important, and you need to grasp all of them, because all of them are going to become very important and seminal to your success in the engineering field. So yes, I believe that we have great engineers here in Jamaica, and there's also great engineering opportunities here for Jamaican engineers who are being trained. You have the brain drain issue, but those are for other reasons. And as soon as our guys get over there, they start to realize how great being the Jamaican experience really is, you know, and you start to realize that, as they would say, nowhere no better than yard, you know. Those are my few words.
Thank you, Mr. Johnson. Mr. Small, Mr. Case, do you agree? And in the same light, is the highest demand for engineers locally in the power industry?
I think the engineering has changed a bit because you have what we call convergent technologies. So because of convergent technologies now, you have, I think electrical engineering has naturally blended to include a lot of IT, a lot of telecoms, a lot of even going over into the geospatial environment as well, right? So it has morphed, and it needed to morph based on where the world is going, right? But I do agree with Jervis because I think it's a suppression type of thing that we should not subscribe to. We have been receiving, and not just in JPS, but many Jamaicans have received a lot of international awards for the work that we do here in Jamaica. And oftentimes when the consultants come, they basically pretty much rubber stamp what we do. There's one thing that's unique about the Jamaican experience, and Hugo said it. So, you know, Mutty Perkins used to say in the old days that one China can do 10 somebody work. He always used to say that, right? But I suggest to you that one Jamaican engineer can probably do 10 engineers work in another country. It translates in the reverse, going the other way. Because our experience is that we have to know everything versus the work that we've seen our colleagues do in other countries They are just so lane focused on their own discipline that there's very little interaction outside of their own lane, right? To support the engineer. So we have a richer engineer base, I think, here in Jamaica. We have to know about water, we have to know about environment, we have to know about civil, we have to know about so almost all of the things that our skill sets, we have to bring it to bear, right? I see Hugo over there. Just the other day, something come across my desk, and I said, "What Hugo doing in electrical?" Right? So you realize that the skill set that we have to support the work that we do in Jamaica, it's novel, and it translates in a multiplier way when you take it overseas. So that's my experience with it, and it's much more rewarding for you because you can run in any race in any lane. You can change gear at any time, ramp up, ramp down, you name it.
Thank you very much. And Mr. Small?
Over the past years, we have hired, even in my division, engineers out of UTech. One of the things that JPS has running is an internship program. Run through our HR group with the University of Technology. And up to as recent as 2019, I think I brought in two engineers fresh from out of graduation, right into UTech. We actually worked alongside with them doing their major projects, right? And from their major projects into that internship program, right? They basically are now full-time employees in my staff, right? And I have done quite a lot of major projects with UTech students. Jervis and Ricardo can also say the same thing, right? So, and these youngsters who are working for us now, right, are right up there with the best in the country, but in the world, right? So this is to say to all electrical engineers, this thing is bigger than technician, right? The power field especially has a lot to offer in terms of electrical engineering, right? But what power also does, it makes you so well-rounded because our engineers right now that did electrical are actually working in mechanical fields. Some of them are working in processing and instrumentation down by some of the power plants, right? So there is a bright future in of electrical engineering. And the key thing about the Jamaican landscape is that when you combine our practical and our practical skills and our experience with the things that you learn in school, right? You can go anywhere in the world, right? And be a top class engineer, right? Better than even some of those engineers that are being produced by other overseas institutions that do not have that same practical experience or know-how that we can do, similar to what Jervis said. So all you need to do is in school, you make sure you merge the theory and the practical and have a kind of discipline and a mindset to come out now and to execute. And once you do that, there is always some form of opportunity that is waiting out there, right? And you can fill those gaps as long as you are willing to evolve and to innovate. Right? The world of electrical engineering is just starting. So don't hold your heads down, right? There's a bright that's out there for you.
Thank you so much, Mr. Small. I really appreciate the feedbacks that we've received. One thing I'm sure that you can take away from this is that there is greater, there is more, it is bigger than technician work that is waiting on you. And to all of you electrical engineers, you know, you have emphasized how excellently individuals are functioning within the field. I'm proud to hear you speak well of students whom you've taken a chance on and, you know, who have shown that they were worth that chance. And I'm sure your colleagues are proud to hear you describe them as some of the best engineers in the world, right? So thank you very much for that. On the soft...
Chevelle, I don't want something to go missing, right?
Right.
Do not subscribe to the mindset, because if you come into the workplace with that mindset, you're defeating yourself. because you might end up staying in that lane perpetually. You have to come in, and we have seen it. Lincoln spoke about the internship program, but like in the last 2 or 3 years, we got some very excellent engineers from UTech, right? That they fit easily into the mindset that we want. So they were much easier to work with. But we have seen those who subscribe to this, I am not good enough mindset. And I want to ensure that for your viewers, the persons on the chat, don't come into the workplace with that. It will follow you around.
Thank you so much.
All right.
I'm sure Ms. Walters can relate that the mindset is extremely important when it comes to working in the field, right? As it relates to automation, Ms. Walters, just mix it up a little and head over into the chemical field. As it relates to the mindset, how one of our viewers asked, how can us as young engineers heading into the field use automation to help? Do you think the field is open to that?
Thank you. I think the field is definitely open. I'm not sure is it that they want to use automation to optimize the processes or their respective engineering fields or is it that they want to get into the field of automation? Regardless of which it is, the field of automation is very open. There are a lot of opportunities here locally to work with companies, particularly in the bauxite, alumina, and the petrochemical industries for both chemical engineers, IT professionals, and also electrical engineers in the field. And there are a lot of opportunities internationally too in the field.
Okay. Thank you very much. And a yes or no question to the electrical engineers. Is there a lot of coding happening in the electrical field currently? Programming
Yes.
coding.
I mean, most applications, you can buy them for purpose now. You might have some customization that you will have to do for your process, which might require a little coding, but for the most part, industry standards, the processes in Jamaica are not necessarily unique to Jamaica, but for any small customization that you have to do. And a lot of times the vendors themselves may do that coding.
Awesome. Thank you very much. Now we're aware that
I just want to add something for both of the questions that you just asked, one for the automation one. Yeah, so as Jen already mentioned, there are lots of opportunities out there, and automation really is a big industry. For all the fields that are represented here, automation is touching every single one of them. And tying into what Rick had just answered in terms of the programming, both automation and programming, that they do have a lot of things in common. So one thing I can say for the upcoming graduates, the first year, second year, doesn't really matter. Just if you wanna play a role in that field and prepare yourself a bit for it, just start a project on it. That's something that I did coming from second into third year. Did some work online, taught myself some programming, into the competition, and we won. So that's something that didn't require a lot of investment. It just took some time. But coming out of college, I had a project on my resume that I could speak to, one that we competed internationally with as well. Rick and Linkoy and Jervis mentioned that in terms of us comparing our engineers to the international group. And so even when I was entering that competition, I didn't think much about it. We were in Atlanta. I didn't think I would win, but I just wanted to represent myself, represent the country, represent UTech. I knew what we had was good quality. And yeah, the big schools were there with the big budgets, but we still beat them. So what I'm saying is that anything that you have an interest in at this stage in college, find a project, do some work on it now. So by the time you're done and you go to an interview, you can speak definitively on that topic, even before you you enter the working world. So if you want to go into something, find a project that you can work on, doesn't require a lot of money, and you can basically get yourself some experience.
Awesome, thank you. Mr. Tai, continuing on the topic of technology and automation, I don't know how applicable is automation to your field. You could tell us a little about that, but how much software do you use? How frequently do you interact with it? And what are some of the softwares that you use?
Oh, whoa. Let me address the automation portion of the question first. Well, preface the whole answer by saying that civil engineering is a very broad and diverse specialization, if you will, of engineering. There are many different fields, myriad of different opportunities for persons to specialize in, and the applicability or the prevalence of automation varies depending on what field or specialization of civil engineering you may find yourself in. What I will say though is outside of construction, automation you may find can be involved in a number of the processes that direct themselves to an end product within civil engineering. Well, I'm in the transportation sector. So when it comes on to automation, for example, a number of, typically automation for us really lends itself to ensuring that there's quality in the products that we use to put together our structures. And that is essentially, as I said, where in terms of the processes where automation comes into play. The materials that we use, ensuring that they're up to standards, up to specs, and automation really ensures that we reduce inefficiencies or reduce any opportunity for bad portion of, say, a block or whatever is being made. The next portion of the question you had asked, or can you remind me?
Oh, sure. What are some of the softwares that you interact with?
Okay, right. Wow, and again, civil engineering is very broad. But I suppose speaking within structural, although I'm not particular structural engineer, when it comes down to drafting, there are a number of different drafting softwares. I mean, the popular ones are AutoCAD. And well, for me in particular, in the transportation in industry and highway engineering, I use a lot of Civil 3D because we tend to work a lot with in civil works. So when it comes down to quantities and earth structures, putting down roadways, Civil 3D is a good software to use. I mean, structural engineers use a lot of Revit as well. There are a lot of structural analysis softwares, LinPro, STAD, Tekla, TEDS. Even in transportation, we have a number of analysis softwares. We use Synchro, which does traffic simulations. There's Sidra, and I'm sure there are many more when it comes down to environmental, geotechnical engineering, coastal engineering. I think a lot of, well, some programming as well is used. There's Beach, there is Mike 21 in coastal engineering, and there's a bit of coding as well. Well, to some extent, I know they use, well, engineers in typical, we might use MATLAB as well. So the softwares are wide and varying, and there are a plethora of them to encounter in civil engineering.
Amazing, amazing. Thank you. I'm sure our students are happy to hear some softwares that they're familiar with, right, students? I mean, the viewers are asking though for other fields. So Ms. Plummer, could we go over to chemical and you tell us what are some of the softwares that you use and how frequently?
Okay, using during lecturing or in my
within your field, right? Within the field.
Okay, so during the lecture and all the modules, I mainly focused on ChemCAD. During my business hours, I don't use any kind of software in it because it's just strictly lab-based work that I would do in my business. However, with lecturing the students, I mainly focus on not AutoCAD, ChemCAD.
Ms. Waters, so she pointed to automation. What are some of the softwares that you use? I believe that you would use quite a few.
Okay, so yes, we do use a few softwares. Our department and Jamalco works in alliance with Honeywell. So we use mostly Honeywell proprietary softwares, inclusive of something that we refer to as native window, but pretty much it's a software application that allows us to configure control schemes. In conjunction to that, we also have display builders that actually allows us to build the displays and the interfaces that the control room technicians will also interact with. And those are also Honeywell softwares. We have PLC softwares, and that is Control Logix 5000, which is Allen Bradley. And in conjunction, we use control language, which is a high-level programming language that is a little similar to MATLAB. It's not the same, but it has the general principles or coding principles that you learn in MATLAB or C++ language. And just to point out that this is not limited to chemical engineering, the process control department and automation department, as indicated, it encompasses various fields. So we have electrical engineers, chemical engineers, and also IT professionals that would use these softwares in an effort to automate the plant processes. And we also have what we call advanced process control and advanced regulatory control. And the source of the software that we use in the configuration of our applicable control scheme. So there's a lot of software. As indicated, you may not know some of them by name because they're Honeywell proprietary software, but it really will follow a similar principle. So what you will learn in MATLAB, C++, what you will learn in process control and dynamics is just really the software version of those really core principles that you learn throughout your degree.
It's really amazing. So especially the allusion to MATLAB, something that the students are definitely familiar with. We really appreciate that. So thank you for that. And thank you for the list of softwares. To any of the electrical engineers, would you just list some of the softwares that you use just the same?
So we use quite a bit of software. There's energy management software, which basically covers the full, which within itself has several different applications built for purpose for solving different problems on the network. So for example, voltage control, there's a software for that. Just like how you'd say there's an app for that. But the foundation of a lot of the software that we have is the GIS, which is the Geographical Information System. Everything is going spatial now. So you find that there's a lot of integration between the physical space and the electrical space, put it that way. So for example, a smart meter that JPS might deploy has several functions within it. The smart meter has a physical location somewhere on a network, and that network is connected to a series of elements all the way back to the power plant. So all of that kind of constitutes a model itself that is reposed in several different software between the smart meter and the generator itself. And it would be too much to list all of them, right? And then on the design side, I was talking to you before the podcast that even for transmission structural designs, so we design transmission towers, poles to carry power from right across the island, distribution networks to carry power from right through the island, which has structural elements to it. So we have engineers who basically are kind of on that hybrid space between civil construction, and electrical at the same time. And there are software for that. So you have PLS CAD that you can use to do software like that. You have within the ArcFM space design software designer that allows you to build out distribution network underground systems, do power flow simulations on it, and even create a list of material to go and order, right? So the world has come together to solve a lot of these complex problems, and take that big bull cow and boil it down to a small cup of soup, and that's kind of how we operate in this space.
Take that big bull cow and boil it down to a small cup of soup. Amazing. Now, we thank you for the comment, especially that everything is going spatial, and it's possible that this is an area that as young engineers we can focus on. So what some of my lecturers have advised is that we take these softwares and we look into them and we try to learn some of them. Of course, you have tutorials. YouTube is a whole university for itself right now. So we're able to use information from that to help us to learn these softwares independent of what we get to cover in classes. And that is exceptional. That also helps for our final projects. So thank you very much for that. Mr. James, I believe there's a question that you had for our, is it chemical engineers? Michael?
Well, I mainly wanted to know, because we have both females, both chemical engineers are females, right? And I'm sure we have a lot of female engineers in the chat. Oh, three, my bad. So I just wanted to know the diversity in the field in terms of engineering and women in engineering, right? Engineering is deemed as a male-dominated industry. So just give us a little insight as to how dominated is it, or how diverse the industry is when it comes down to female in the industry.
Well, when I was working as an engineer, how long ago was that? 2007 to 2011. There were not many female engineers where I was working, and it was about, I don't know, maybe about 5 of us. So you would find that in a meeting, etc., you'd probably be the only females there, etc. But I mean, to me, at the end of the day, you're an engineer, and whether you're male or female, that doesn't matter, because we all went to school to study engineering, and we're all capable regardless of the sex that we are. So I don't know how much it has changed, but based on my classrooms, I don't see that much changes, to be honest with you, as it relates to the amount of females who are coming in, because I would be teaching introduction to engineering my first years. And when I look around in the class, let's say that group is 25 students, I have 3 females in that class. So perhaps Jan can speak of it how it is now within the industry, but from the student perspective, regarding the amount of females that I see coming in, it is pretty much the same as when I was at university. But at the end of the day, we're all capable of doing the job. We're all studying, and we're all, we all had to do exams, etc., to get to where we are. And we apply ourselves as well. So I don't think whether you're a male or female, it should really matter when it comes on to being an engineer and working in the field. But Jan, I'm sure you might have something else to add to it.
Thank you, Diane. Well, for me, I'm in chemical engineering. And as you guys are aware that we have the highest percentage of female engineering graduates in that discipline. So I have never felt marginalized as a chemical engineering student in the chemical engineering field. And currently where I work at Jamalco is an equal opportunity company. And I've never been made to feel marginalized because I'm a female. In my office, there's about 50% females working there. And however, plant-wide, obviously, it is male-dominated, particularly in the mechanical and electrical fields. But as you rightfully said, Diane, we have the same level of training, a lot of times the same level of expertise. And I believe that whether you're male or female, it all boils down to your work ethic and hard work And I've not felt marginalized because of my gender in the workplace, even though a lot of times I may be one of few females in the room in certain meetings and on certain occasions. There may be one or two occasions where I felt that maybe, you know, I had to talk a little louder than normal just to get people to listen to, or, you know, to hear what I was saying. But, you know, that's a part of it. And if I have to be one of few females and I have to do that, then that's fine with me, because in that way I'm paving the way for other women and for other female engineers. And I must say that the female engineers that I've worked with over the years, not taking anything from the males, they have been exceptionally well. They've done exceptionally well, and they have been exceptional engineers. And I am proud of where I work in terms of being an equal opportunity company. And I do not feel marginalized, and I do not feel as if being one woman in a room or one of two in a room makes me less competent to do my job, and it certainly does not deter my confidence.
Well said. Well said.
Wonderful, well said. So for in like mechanical as well, Mr. Gordon, let's bring you in here. Do you see that the mechanical industry is still are predominantly male? Do you see females, you know, drawing closer to the mechanical discipline?
Yeah, I mean, we don't have any mechanical female engineers at HTG, but I've come across a couple, and as others have said, I mean, listen, I mean, guys, the world is changing. You know, there are equal opportunities right across the board. So I think no one should really be, you know, put off by any pursuing a particular path because you're a female or a male. I see changing. I mean, you know, we see patterns. So yeah, no.
Thank you.
So just to segue, in terms of mentorship, right, and experience and all of that, right? One of the things that we're told, you know, that is good to have is experience. You know, I know embedded in some of our programs, you have something called the industrial work experience, where, you know, we're in the field with some of the companies that we potentially would hope to work at, right? Now, this is a double barrel question, I guess. Now, one person had asked in the chat now, seeing that it was mentioned that we could get assistance from mentors, would anyone on the call be willing to act as a mentor? That's one. And I would hope for, so that's more like a question for everybody. You know, how willing are engineering companies outside of the school curriculum, for instance, the industrial work experience, to take on young engineers, to give them experience while they are in school?
Yeah, man, I'm open to it, and we've done it a couple of times already for some students at UTech, you know, one of which is there right now, Kadisha. So we've done it already, and we're open to doing it further.
So I've been a mentor for many years. I am also on the academic advisory board for the engineering division at UTech. I'm also one of the invigilators who deal with the major projects as well. I'm one of the external examiners, and I use it as a recruitment. And I'm not ashamed to say it. We have actually, going back as far as maybe 8 years, I've used the major project presentation as an input to some of our needs. Very selfishly, we have designed programs, assigned projects that serve our purposes, as well as using it as long-term interviews, then put it that way, right? And we have, as Lincoln mentioned, what we call an incubator process, where once we get those engineers in, then we turn them very quickly within 1 year into some very great engineers, right? So I plant myself at UTech for the examinations. We challenge the system because we want to see the quality of such a high level. For example, project management was not a part of your major project thesis before, and we developed and ensured that project management now is actually a part of your delivery, and you cannot present your major project without um, showing the business case for that project, because that really is what you solve in the real world, right? Engineering can go so far until you reach a finance man, and then it makes no sense, right? So all of those things have transformed, and I am open to doing the same type of mentorship that I'm doing now, where we come down and select people that have the right attitude, because we really don't have any time for people who don't have the right attitude, and I'm going to put it right out here now, right? The bright people that we see in your engineering warlords group are people who we might be interested in, but we have gone through some of the projects and it make no sense. They're not solving any problems. People come and they have this attitude that we just want to get by, and we have all of these excuses. It going to catch up with you in the real world, right? We have some good, let me tell you, the last crop, last 2 years, we get some real good people out of the program, and they turn in, Lincoln will tell you some of the stories of what they're doing in JPS now for us, right? And it's just because we go out there, we have the eye, we see them. And we know that they're going to leave us soon, because people are knocking on our doors trying to recruit the people who we have developed at the same time, right? But if we can get the best out of them while they're working with us, we'll take that, right? But we're about developing people. Right now we have 4 people, maybe you know them, Zandre, McDonald, some of the people who would have just graduated working with us now, and they're working on big projects already. And I said it to you, Chevelle, that right now we have a big project coming up. It sounds like something that could fit right into your major project. We would gladly give that to you and support you through financing or otherwise to bring that project to reality in a year. And that is how we operate.
Thank
Right?
you very much.
We deal with results.
Thank you very much. Go ahead.
I want to add something, just adding on to what Rick had mentioned. That's something that I benefited from at Jamalco. I had a summer internship there. It wasn't necessarily organized through UTech. I had just applied and I got to work there for the summer. But what I want to say is that one of the benefits of studying, at UTech, studying in Jamaica, starting at one of our Jamaican firms, even as a summer intern, you're gonna be thrust out there into the deep end with projects that it might only be years later, you might even realize how significant they are. And you'll be given big work to do, a lot of work, long hours, even as a summer intern. And what you'll gain from that, you can't even put a dollar value on it. And you will be able to get mentorship even from as high as CEO level, just as an intern. And what that does for your career, it puts you many years ahead of your counterparts globally. And if you utilize that opportunity as a summer intern, it will fast track you. So that really helped me. So when I started that internship, my parents just said to me, like, just go out there and do your best. And I give it my best shot. And then by the time I had finished at UTech, just because I knew that I did everything that I could during that internship, I knew that really was my interview. So when the interview eventually came a few months after finishing college, while it still wasn't, I still had to prepare. I still had to go there, having every area covered, right? But I knew that the interview was really the year before while I was there as an intern. And the fact is that you will be there as an intern, and there will be influences that will be leading you along the wrong path, right? I wasn't the only intern there, and you're not entitled to anything. and you do not have to be given a job, right? So you have to put in sometimes maybe long hours. Sometimes you have to come with new ideas, new sensible ideas, as Rick has already alluded to, because we really are here to bring value. As simple as it might sound, we really are here to bring change to the world. You know, you might not see that when you're working on the Laplace or when you're doing the statistics, but underlying all of what is happening in the world as an engineer, you are here to bring some positive change through your work. So you're not entitled to anything out there, but you have to go out there and seek it. And it starts from right when you have that summer internship, it might be just a few months long, but it really is the best opportunity. And having, say, 3 months or 2 months to prove yourself, that is way better than just having 15 minutes or even half an hour in an interview to prove yourself. If somebody worked along with you for a month or two, they'll be much more interested in taking you on, taking a chance with you. So I'd say that is one big advantage that's there. So I'd say to use it up. And then another advantage with Jamaica is that I think the access to our high quality and our top quality professionals, I think it's much easier to access people at such a high level. So an engineer who is watching this now, it's not, if he really tries, he can get through to Rick or Hugh or Jervis, Link or Jayan, Diane. They can get through to people who are operating at a very high level if they really want to. In the other countries, the bigger countries, I'm not sure how easy that is. So when I wanted to network and meet people who could help me to grow as an engineer, I just had to focus on it. And I found the people. You got through to the people. So I think that is something that it's an advantage that we have to use up, especially at this stage just coming out of college.
I'm especially grateful, and I see Mr. Tai is about to give his perspective.
Right. I mean, I want to jump in here just as a council member for Jamaica Institution of Engineers. I still call myself very young. I'm not sure how much mentorship I can offer someone, but if someone would approach me, I'm very much willing. But as it regards to the Jamaica Institution of Engineers, I know for this council here in particular, one of the things that we want to do is to really formalize a mentorship program. And even though that may not be quite formal as yet, I still encourage students, young engineers who might have just left college, to still reach out to the JIE. Let your request be known if it is that you want to have a mentor in a particular field, if it is about academics, if it is project specific, reach out to the JIE, reach out to your student chapters, and we'll try our best to see how much we can facilitate you. And the JIE has a number of different events throughout the years. Which, and I know Demoy, is it? Had mentioned something about networking. That is one of the crucial things as well. When JE has these events and we invite student chapters to participate, you have direct access to a number of sorry, not Demoy. You have a number of direct access to a number of, as you said, high-level engineers. And so make use of these opportunities when there are mixer events, network events. I mean, I know the COVID is restricting a number of that now, but through whatever webinars, through whatever events that we may put on, make use of them, participate. I know the council having just begun, we're trying to establish our divisions. I'm chairman for the civil engineering division. In the coming weeks, you'll be seeing flyers sent out for persons to get themselves involved in the different divisions. Make use of these opportunities. Meet with the division chairs. Send emails to them. Call them if you must, bother them, because we want to develop. And I see Michael there laughing, but we really want to get our young engineers on board and really establish this mentorship program going forward.
I would want to add to that. It can start from when you're working on your project. So I am disappointed, especially sometimes when students are working on projects where they say, for example, they're solving a problem at JPS or in the Jamaica grid, and they don't make one call or one reference to find out how it goes. It just makes no sense. Just like what Raymond says, pick up the phone and call. So when I'm there sitting in a presentation that somebody is giving on a topic that I preside over, and I'm the invigilator, I get upset. Naturally, I get upset, and I go and mark the person much harder than I would just because they could have picked up the phone and called to find out how does it work, right? And those opportunities, just like what Raymond says, we cannot afford to miss that as a small island. You talk about working in Barbados, where these other places. The good thing that we have a unique thing about us being small. It's a big advantage to network, and everybody is just 2 away. You understand? Just one LinkedIn friend away. So use it up, man. Thanks.
Thank you very much. Now, we appreciate everybody's input, everyone's. And we know that the individuals here are people who have lent themselves to mentorship over and over again. And once again, we just want to say thank you very much for that and for continually supporting students, for taking a chance on students, actually. Because someone took a chance on me, and can I tell you how much that just exponentially affected everything that I'm learning and how I conceptualize everything. And I really appreciated that. I could literally see classroom lessons coming to life. You know, as you've said repeatedly, it's what we learned is not in a vacuum, and it will apply when we get into the field. So we really appreciate that. We appreciate your mentorship, and please,
that is so true.
Continue to mentor students.
That is so true. I mean, if I might have a little plug here, I mean, the experience is really good, and being persistent is really important. I mean, I laughed when Engineer Ty spoke about being persistent and everything, because that's how I got involved in JIE. Right? You know, I went to one of the simple meetings, I shook a few hands, I just started talking, not even know what I was going to say. And then I've been an intern at an engineering firm for the past couple of years now. You know, I've seen work from Engineer Gordon. I didn't tell him that before we started the interview. You know, his work is amazing. And just being around engineers, and it does something different outside of just your regular curriculum, right? You know, being around persons in the field, you know, being in their presence, seeing what they do has a great impact. So, you know, you can reach out to them on LinkedIn, you can reach out to them in their different platforms. I know HTGs on Instagram. You can go through the JIE. You know, add them on LinkedIn. I know a lot of I actually followed or added Miss Engineer Palmer today on LinkedIn, right? So, you know, follow them, get to them on LinkedIn, ask you questions, be persistent. This is a field that you want to get into, then show your interest to the persons who are making themselves available to you.
Thank you very much, Michael. All right, so as they say, you know, time is money, and we're almost 10 minutes over. The chat is very lively. They seem as though they would continue for the rest of the night. But what they really are expressing is their gratefulness for some of the words that you have shared. For example, one person said, big up Jamaica engineers. And another person said, you know, this man speaks pure facts. And the comments trail just like that. So
comments say we're realists, and persons are thanking for the experience they've gotten and everything. We could go on and on and on for the whole night, but we did say 6 to 8 p.m. Right? And a lot of your questions are professional registration questions, and that will be answered tomorrow in day 3 of our webinar.
All right, so we want to say thank you very much to our speakers, to Norman Ty, Vermont Goldberg, Miss Jayan Walters, Miss Diane Plummer, to Mr. Case, Mr. Hugh Gordon, Mr. Linkoy Small, and Mr. Jervis Johnson. We are very grateful for your presence here today. And, you know, to our technical team present, we want to say thank you to our viewers. You have received quite a bit of valuable information, and I'm asking you to please Take this information and apply it. You've received more than enough information to help yourself. Don't just let it go through one ears and to the other. Thank you for taking the time out of your busy schedules in order to be here. And thank you for sharing your wealth of information.
It's a great platform. Thanks for having us.
Thank you.
Thanks
Thank
for having me.
you. Nice meeting you all.
All right, thank you.
Thanks.
Bye.
Nice meeting everyone.
Yeah.
Thanks, guys. All the best to you.
Bye.
Yeah, man.
Thank you very much, guys. So see you tomorrow, guys. Follow us on our different platforms to get more information on how you can contact these engineers, right, who have presented a part of our panelists tonight. And tune in tomorrow. Tomorrow is our final day, day 3 of our engineering webinar, expectation versus reality, where we'll delve into, what makes me a good engineer, how to build a good engineer.